Okay, this is lesson 10.6, day 2. It's the second day of the quadratic formula. There's the homework that goes along with it. Here are the answers to last night's homework so you can check it. Okay, on your note packet, okay, we're going to take a look at a real-life application using the quadratic formula. And those of you that are planning on going to college and studying anything in the math or science field, okay, engineering, medicine, whatever, you're going to need to be able to use formulas. Let's read this problem. It says, suppose a football player kicks a ball and gives it an initial upward velocity of 47 feet per second. The starting height of the football is 3 feet. If no one catches the football, how long will it be in the air? Now, let's look at that. You are going to use the vertical motion formula, which, if I gave you this on a test, I would give you this one. Okay, I'm not going to expect you to know this. But look at what this says. Okay? The initial upward velocity is v. And the starting height is c. H is hours, H is height, T is time. Rush it. Now, when you are doing these problems, we are going to plug in the appropriate values. Now, it says the initial upward velocity is 47, so that goes in for v. The starting height is 3. And it says, if no one catches the football, how long will it be in the air? Now, I have a question for you. If I kick the football, boom, I kick it from about here, 3 feet, what's it going to look like? Isn't the football going to go up, down, and what is its height going to be when it hits the ground? 0. So, height is 0 because they're saying, how long will it take for it to hit the ground? Well, the height has to be 0 because that's where it's going to hit the ground. Okay. Now, we plug in our appropriate values. We want the time. Now, isn't that key? So we have to solve this bad boy for t. Well, this problem is a perfect quadratic formula problem. It is already set equal to 0. It is in standard form. So, what value would I have for A, B, and C? Okay, now, we are going to plug it in. Remember, x equals negative b plus or minus the square root of b squared minus 4c all over 2a. Gotta know that. Negative b. So, minus 47 plus or minus the square root of 47 squared minus 4 times negative 16 times 3. That's all under your radical. Over 2 times negative 16. Now, let's clean this up. Negative 47 plus or minus. If I use my calculator here, 47 squared is 2,209. Is this second value going to be plus or minus? Because I've got negative 4 times negative 16, and negative times a negative is going to be a positive. 12 times 16, 192, over negative 32. So I'm going to have x equals negative 47 plus or minus the square root of, when I add these two together, I get 2,401 over negative 32. Now, my two answers are going to be negative 47, this is going to be in parentheses if you're typing this into your calculator, the numerator, plus the square root of 2,401 over negative 32. And my other answer is going to be negative 47 minus the square root of 2,401 all over negative 32. When you evaluate these, you get negative 0.065 and 3. Now, this is a real life situation. We are talking time. Which one is going to work? This is going to be 3 seconds. There is no such thing as negative seconds. So this is what we call an extraneous loop, which means it is an answer to that problem, but in this real life application, the negative value will not work. All right. A football player kicks a ball with an initial upward. We're not even going to do this one. Same exact thing. Okay. This we have already spent a lot of time talking about. We've been doing this for the entire unit. There are many methods for solving a quadratic equation. You can always use the quadratic formula, but sometimes another method may be easier. So, how do you know when to use what? Well, a graphing calculator, that's handy if you have one. Okay. How do you know that taking square roots is going to be effective when you only have an x squared, no x term? Exactly. It's easily factorial. Now, I don't know why Mr. Warzonic crossed this out. I'm going to see if I can erase that. I can't. I think completing a square is a great option when your x squared term has a 1 in front of it. Obviously not written. And b is even. I think that's easier than the quadratic formula if it's of that form. If your x squared term has a 1 and your b value, which is what is in front of the x, is even. Then, quadratic formula for everything else. All the garbage. Okay? So, let's take a look at these problems. A. What would be the easiest method to solve A? What do you think? Yep, square roots. That better be what he has over there. Square roots, because there's no x term. B. Well, I don't know if it's going to factor. I'm going to say quadratic formula. Quadratic formula. I mean, it might be able to be factored. You could try box and diamond, but if it doesn't work, then you have to go to quadratic. What about this one? I would say either completing a square or factoring, because I can look at this. I need two numbers that multiply to negative 15 and add to 2. That'll be positive 5 and negative 3. So I know that it's factoring. Factoring. But I agree, completing the square is not a horrible option. And then, this one. Probably quadratic. Probably quadratic. Although, well, you're going to end up with a horrible looking fraction. If you divide this everything by 16, I don't think completing squares is that great. Alright. Here we go. Let's take a look at these problems. Actually, you know what I want you to do? I want you, right now, to solve these 3 problems. Okay, as you look at these 3 problems, for A, I use the quadratic formula. Okay? And when you get down to this line, you've got a negative under a square root, there is no solution. If that problem is not factorable, it would be a pain in the butt to try and complete the square. So your only other option is quadratic formula. B, solve by factoring. Okay? Solve by factoring. This factors into x minus 6 and x plus 5. So x is positive 6 and negative 5. What's wrong? Oh yeah, this should be 25. I'm sorry. That should be 25. That's going to make this 67. Okay. Yeah, thank you. Then, C. There is only an x squared. I would solve that by taking the square root. Notice, as I'm doing this, I'm thinking, wow, this is awesome, because 25 and 144 are perfect squares. Do not divide that and make it a decimal. Leave it as a fraction. You know you're going to take the square root. You know that they're perfect squares. Do not forget plus or minus. Hold on.